Today we are talking about the last type of transformation that we are going to go over this year, and it is a dilation. So a dilation is different from the other types of transformations, translation, rotation, and reflection, because with those three, it didn't change the size of the figure. So it moved it, it might have turned it or flipped it, but the size of the figure remained the same. So a dilation is the type of transformation that changes the size. So the shape is still the same shape, it is just a different size. And now it's also important to note that this is a change that is proportional for all sides. That means you don't just change one side and everything else stays the same. When you make a change, it changes the whole entire shape the same amount. So when we dilate, we use what's called a scale factor. So the scale factor tells you how much larger or how much smaller your figure is going to be. If you have a scale factor that's less than 1, it's going to shrink the image. If you have a scale factor that's greater than 1, it's going to enlarge or make the image bigger. So when you have an image on a coordinate plane like we have here, and it gives you a scale factor. So the scale factor for the first one is 1/2. I have the 4 points down here, the coordinates of the 4 points. So in order to find the coordinates and draw each new figure that's been dilated, we simply use that scale factor with the points. So if the scale factor is 1/2, then I'm going to take each my x and my y coordinate and multiply it by 1/2 to get my new coordinates. So -6 times 1/2 is -3. So we're going to call that a prime. So it's going to be -3. And then 4 times 1/2 is 2. So a becomes -3, 2. B prime would be 0 times 1/2, which is 0. And then 4 times 1/2, which is 2. So again, I'm just taking the scale factor for this problem, 1/2, and I'm multiplying it by both my x and my y coordinate for each of my points. So C prime, well, that's 0, 0. So those are both going to stay 0, 0 because 0 times anything is 0. And then D prime, I'm going to multiply -6 times 1/2, so that's -3. And then 0 times 1/2 is 0. So those are the new points for our dilated image, dilated with the scale factor of 1/2. So since 1/2 is smaller than 1, it's going to become a smaller image. So A prime is at -3, 2. So we're going to go over -3 up 2. And that is A prime. B prime is over 0 up 2. And so that is B prime. C prime stayed at 0, 0. And then D prime is -3, 0. So this is our dilated figure. It is half as large as the original figure. So the original figure, this length was 6 units long, and now it's 3. The original figure, this length between B and C was 4 units long, and now between B prime and C prime, it's 2 units long. So that's the dilation of that figure by 1/2. Notice it's the same shape and that everything was shrunk down by a scale factor of 1/2. So let's look at the next one. The next one, I have a scale factor of 3. So since it's greater than 1, it is going to get larger. So A prime, A is 1, 1. So with a scale factor of 3, I'm simply going to multiply each of those by 3. So that becomes 3, 3. B prime, B is 3, 1. So 3 times 3 is 9. 3 times 1 is 3. And then C prime, C is 3 and 3. So since I'm using my scale factor of 3, I'm going to multiply each of those by 3, and it's going to be 9 and 9. So plotting my new points, A has become 3, 3. So over 3, up 3. B has become 9, 3, so over 9 up 3. And C prime is 9, 9. So this triangle is now 3 times as large as it was. So this original side length AB, it was 2 units long. Now it's 1, 2, 3, 4, 5, 6. 3 times as long, 6 units. And same for this length between C and B. It was 2, and now it's 6. One thing you might have noticed is that in our first figure, it stayed, like it kept a point, and that's just because that point was at 0, 0. Here we didn't have a point at 0, 0, so all of our points moved. So it only stays like that if one of your points is at the origin or is at 0, 0. Otherwise, all of your points are transformed. So again, notice this triangle, it's the same shape. It has just become 3 times larger. So with every transformation, we've had a coordinate rule, and dilations is no different. So for this coordinate rule, since we're using variables, we're going to pretend our scale factor is k. That's what we're going to call our scale factor. So if we have a scale factor of k, and we are dilating our figure, our point xy becomes k times x and k times y. Again, where k is just a placeholder for your scale factor. So to find your new point after a dilation with the scale factor of k, you multiply k by your x and k by your y. All right, and now for this next part, we are just going to look and see whether each transformation is a dilation. So we've talked about how a dilation is proportional. So let's look at our first one. So if we have our smaller rectangle, we're going to say that's our original. This side length is 2, and this side length is 3. And our larger one, 1, 2, 3, 4, 5, 6, this is 6, and this is 4. So the ratio of these side lengths should be the same. So if I took my larger side lengths, let's color coordinate this a little bit. If I compared these two, I can tell that's twice as big because 6 divided by 3 is 2. And so when I look at my other one, I can also tell that it has been multiplied by 2 because 4 divided by 2 is 2. So it is a dilation because these ratios are the same and the same scale factor was applied to all of the sides. So on number 2, let's look at the side lengths, 1, 2, 3, 4, 1, 2, 3, 4. And then the bottom here is 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. Okay, so looking at this, we can see if I look at these lines that are both 4, well, 4 and 4 are the same. So 4 divided by 4 would be that ratio, and that's 1. So if I look at my other ratio, 6 to 5 isn't 1. It's not the same ratio. So it's not going to be a dilation since they don't have that same ratio. So that's 1.2. So in order for it to be a dilation, each side length has to be the same ratio or has to be using the same scale factor. So on this first one, our scale factor was 2 if I'm going from the smaller to the larger. And so since that scale factor existed and both of the side lengths were multiplied by that, it is a dilation. On number 2, though, you didn't use the same number to multiply. 4 times 1 was 4, but 6 times 1 is not 5. Or, 5. I said that backwards. 5 times 1.2 is 6. So those aren't the same. You're not multiplying by the same number, and therefore it's not a dilation. Just because it looks the same doesn't necessarily mean it's dilation. You have to look for that scale factor and look to see that those ratios are the same. So we've kind of already talked about this, but dilations change the size of an image, but the side lengths must stay proportional, and then your angles also stay the same measure. So this is a new word for us, but we'll talk more about this in our next lesson as well. But these figures after a dilation are considered similar And we'll define that more. It means that they look the same, but they're different sizes. And they have that proportional relationship, that same scale factor. But they're not congruent. Congruent means exactly the same. So they're not exactly the same shape because they're not the same size, so they're not congruent. And again, we'll talk more about that in our next